Next speaker here, his name is Paul Lee. Paul is in Seoul, Korea. One of my favorite cities, actually. My favorite #1 is Busan, and he promised he's gonna take me to Busan one day. So I'm like, I promise to bring you to Toronto. Paul is a clinician, scientist, and an entrepreneur. Paul is the founder and CEO of Mind.AI that leads the endeavor of open and decentralized AI worldwide. One cool thing, and a full disclosure to folks, up until last Thursday or Friday, when I was speaking at the AI for Good Summit, we had no deal whatsoever with Paul's company, and I had the pleasure to see a lot of his technology, and openly in front of a lot of folks at many panels, I disclose what I truly think about the technology Mind.AI without being associated with them. But for now, it's full disclosure. We do have a joint venture together. So we did my company, Toda. We made, so we have a baby together. It's called Mind on Toda. I'm not going to say a lot of, like I said, I don't like self-promotion, so I won't say a lot of great things about Mind in this event, but I encourage each and every one of you, those that they know AI deep down, will discover for yourself what a fabulous technology it is. So he received an MD from the School of Medicine at Catholic University of Korea, so he's also a fellow Catholic. Hey. Paul is also a graduate of Futurement at Singularity University 2013 and Exponential Medicine 2014. As CEO and co-founder of Curely and Cuddly, he grew the platform into one of the largest media channels in the United States for the health and pet health industry, with a viewership of over 6 billion. Please help me welcome Paul Lee.
Hi, it's great to be here. Thank you for your attention. Thank you for your applause. So let's start. So I'm the founder and the CEO of Mind.AI, but today I want to focus on the waves of how AI has developed. So a little food for thought. So I was in Geneva last week, and I was with Stephen Ibraki, who's sitting over there, who was the chair for the ITU. And in that conference, there were 3 questions from the audience that really stood out. And I want to share it with you right now. So the first one was, how do we incentivize young AI researchers and basically don't lose them to the Googles of the world or the Facebooks of the world, and help them do good for the AI? The second question was, okay, so right now the machine learning is great at spotting patterns, but how do we allow it to reason? The third question was, so how far are we from artificial superintelligence? Is it going to be in 5 to 10 years? Is it even possible? So the first way of AI, it was literally traditional programming. For example, the Windows operating system, the smartphone apps, even the traffic lights that you had to press to cross. Now, these were handcrafted knowledge, which means engineers create sets of rules to represent knowledge in well-defined domains. It had no learning capability and very poor understanding and uncertainty. The second wave of AI, which is prominent today. So neural networks and deep learning, there's input nodes going through a little black box, and then it comes out on the other side as an output. The problem is the transparency. You have no idea what's going on inside. And if it's applicated to, for example, medicine or drug discovery, would you be able to trust the conclusion or the output? So second wave of AI is concentrated on statistical learning. Engineers create statistical models for specific problems and allow the use of big data, tons and tons of data. For example, the AlphaGo, it can beat the best of the best in the game of Go, but it doesn't realize it's playing the game of Go. So can that be considered artificial intelligence? So it does not do contextual capability, minimal reasoning ability, It's statistically amazingly impressive, but individually very unreliable. It can also be skewed in how you train and what kind of data you use as well. So what's next? But before going into that, let me give you a few quotes from DARPA, from the founder of Google's DeepMind, and the pioneer Geoffrey Hinton. So DARPA says, the third wave, the AI systems themselves will have to construct models that will explain how it works. The key word here being explain. The founder of Google said, well, the AIs out there right now are all good, but it's not exactly intelligent. The deep learning pioneer, Geoffrey, what he said was, I think we need to throw everything away and start fresh. So the third wave of AI. On your left, you can see a diagram of what we consider as the unit of reasoning. It took us 12 years to get here. 12 years of blood and sweat. But what it does is it's a contextual adaptation. It's transparent, and it models to explain decisions and output. It's in real time, it's interactive learning, and it's self-directed learning. I'm going to explain more. But let's compare second wave with third wave. I gave the example of the cow in the panel, but seriously, how many of you would look at this and say 87% that's a cow? We don't think like that. Human beings do not think like that, and we reason. That's how we are different from other machines. And the third wave of AI will look at this and say, okay, there's 4 legs. Okay, it has hooves, it has an udder, it's spotted, so it must be a milking cow. That's how we reason as human beings. And we're saying, can a machine do that too? So what is reasoning then? Reasoning consists of thinking, cognition, and intellect. But in order for you to say reasoning, it needs 3 components, all working in concert. Abductive reasoning, deductive reasoning, as well as inductive reasoning. So only when they work all in concert, all work together, can we say it's a reasoning engine. So we don't need supercomputers. We don't need tons of data. The core thing is that we have a reasoning engine that makes sense of unstructured data like natural language. It allows natural language to be put into this unit of reasoning structure and allow it to be processed and reason itself. So whether it's a problem, whether it's reading a Wikipedia article, it will understand it and it will be able to talk to you with it. We have an international patent on it. But what's the main difference? So it's a new symbolic paradigm. I'm sure you guys all know about the good old-fashioned AI in the 1950s. It was built on a symbolic paradigm. The main problem with the symbolic paradigm was the brittleness. We solved that through augmented topological network. As you can see in the diagram, the canonical keeps on rotating, and it feels that the canonical, it can be a link, it can be a node, and a canonical can be a link and a node as well. It's linear, qualitative, and it's human understandable logic, which means you can trace back. You don't need tons of data. Rather than giving it lots of playing data about Go, we can tell them exactly what and the rules of playing Go, and it'll be able to play it. The transparency. This is a crucial problem that we have today. The second wave AI will not solve it, and we need to solve it in the third wave. Also, right now our core engine is any language, so language agnostic. It's universal. It doesn't just play games, it can actually be put into real life domains such as finance, such as drug discovery, and whatnot. We need to make it open. We have to. We need to allow the global development community to have access to the machine, the engine, and allow more further innovations to happen. It has to democratize AI. Not just concentrating the power of AI in one company, or one country, or 2 countries rather, but we need to decentralize it, allow people around the world to participate, and allow innovation and move humanity a little forward. The beauty of having the core engine of reasoning is that it allows to learn it on its own. And further on, it will be able to form meta-theoretics. That means it can form theories on its own. It's scary, yes, but it's inevitable. We need a governing structure, of course. But let's think about the good in us, the good in the humanity, good in the community that we're going to build around this core engine. So future and beyond, drug discovery, shopping assistance in e-commerce, virtual mentors in education, automated coding. What about asset management in finance? Diagnosis, new treatment paradigms, personal secretary like Jarvis and Iron Man. But this is only the primary goals. I want to give you an analogy of electricity. Electricity was formed and it was built for a light bulb initially. That was the primary application. The secondary application is started to feed in and power machines, refrigerators, microwaves, computers. Then the tertiary happened, the internet. Without the computers, no mobile phones would have happened, no internet would have happened. The quaternary goal, the further on, you have the companies like the Amazon, the Facebooks. So innovation happens whether we like it or not, but we don't know how it's going to happen. So we need to let the community decide and allow the community to evolve around it. So this simple structure, going from primary to resultant, it always needs a context. And this is what we call the unit of reasoning. We're not saying we've cracked AGI, not at all. But we are saying that we've scratched the first surface, and we think we have something that the world can work on. So let me finish off by showing you a video and see how this goes.
Artificial intelligence is the new arms race of our time. With the world
What we're urging you is to look at the good side of AI and look at the good side of every one of you. And that will allow us to form the community that we need to help us move forward and really bring the humanity to the next level. Thank you. So before I finish, I do want to say a little thing about Mind on Toda. So as you've heard from Tufi, we've just created a baby. And the blockchain that we're on, which is Toda, will allow the ontologies to be stored in a much more secure, safe, and scalable way. And it's going to be much more efficient. So we're very, very stoked about this. And you know, there's a lot more to come on the Mind.Toda, but also the Mind.AI. Thank you for your time. Thank you.
I'm super excited to have a joint venture with them. And again, I won't talk much about this, but it's the only thing I say is that when two people like each other so much, end up having a baby. When two companies, they like each other so much, end up having a joint venture. So we also call it a baby.